Module 1 is nothing but an introduction of the basics, and it can fetch you a lot of marks if you know these basic concepts. So let's start. The first topic is array. Okay, array, if you don't know, it's just a space of in the memory which is divided into many parts. Now how will I initialize this space in the memory? What I will write, int a, in square brackets I'll write 5. What will happen, 5 spaces will be allocated in memory, and in which I can store the numbers. Okay, and this memory allocation has the name a. Okay, int means integers can be stored in it. Now the first operation is insertion. Suppose I have to insert an element. How will I do that? A of 0, this is read as a of 0 is equal to 1. What does a of 0 mean? This is the array which has the name a, so a of 0 indicates this space, that is equal to 1. So what will happen, at the first space 1 will be inserted. All right, that is insertion. And deletion means, suppose I want to delete one of those elements present in the array. So what I will do, if I have to delete 22, okay, what I will write, a of 1 is equal to 0. What is a of 1? A of 1 is this, right? This will become 0. So it is as if the element has been deleted from the array. All right, now display. In display, what will happen, you have to display all these elements. Now I'll start from 1, then I'll display 2, after that I'll display 3, then finally I'll display 4. How will I do that? I'll use a for loop. Now what does a for loop mean? In for loop I'll write I is equal to 0, I less than n, I plus plus. What do these terms mean? I is equal to 0 means I will be 0 here, means this will be pointed by I. Now I have to print this, right? So I'll print a of I. What does that do? A of I means I is 0 initially, so a of 0 will be printed, and in the output you can see 1 here. Now next, I plus plus. After printing, this will go to I plus plus. I plus plus means I will become 1. When I is 1, this will be printed again. It will go to I plus plus 2, again 3, again 4. When it becomes 4, what will happen? I is not less than n. I is equal to n. N means number of elements. 4 elements, right? So n is 4. When I also becomes 4, 4 is less than 4, it's wrong. So this code will be getting over, all these elements will be displayed. The fourth operation is searching. In searching, what you will have, suppose you have to search the element 23, if the element is present in an array or not. Now what I will do, I will create a variable item, and I will have the element which I have to search, which is 23. Then I will use a for loop which runs from 0 to n, and if item is equal to a of I means for each element I is equal to 0 means first it will compare 23 with this element a of 0, then a of 1, 23 with this, 23 with this. When the item will be equal to a of I, printf found. So at this position a of 2, item is equal to a of 2, so printf found will be printed, and that means the element is present in the array. See, we had integer for storing the integer values, character for storing the character values. Suppose I have to store both of these in a single entity. So what I will use, I will use a structure. In structure, what will happen, you can store the number as well as the character in one separate space. Okay. So how will I initialize that? I'll use the word struct, then I'll use opening braces and the closing braces. Inside that, what I have, int number and char alphabet, means I can store the number and the alphabet as this representation here. Okay, a number and an alphabet can be stored in the same space. That is a structure. Now another similar thing is union, int number and char alphabet. But one thing is, see here, in union you can store the number or the alphabet, okay, but you can't store both at the same time. Suppose I stored in union 1 will be stored, then I stored a, this 1 will be overwritten by a. Whereas in structure it is not the same. In structure you will have independent spaces for each of those items. Okay, so if you want to access 1 after storing a, you can't access, but in structure you can access, because 1 is stored in a separate space, a is stored in a separate space. Okay, that's the difference between union and a structure. Consider there is a box in a big room, okay, and that box has a name a. That box has some number in it, 1. So if you want to know where that box is present inside the room, the location of the box inside the room, that is given by this value, which is the address of that location. Same is for memory. Inside the memory you will have a variable and the name and the location for it. And if you want to know the location, you can store that location in another variable. That variable is called as a pointer. How you will initialize that? int a is equal to 1, what it will do, it will create a box which has the number in it, and that number's location is given by ampersand a. If you use ampersand a, that location will be retrieved and that will be stored in star p. Star p is a pointer for storing the locations of the boxes in the memory. There are 4 functions: malloc, calloc, realloc and free. Now what's the difference between all of this? Suppose I use pointer is equal to int star malloc 20. What will happen? Inside the memory 20 bytes will be allocated, and that memory will have a location that will be stored in the pointer. Alright, did you understand? The memory will be allocated which is of 20 bytes. If I write here malloc 20, 20 bytes will be allocated. If I write 30 here, 30 bytes will be allocated, and that allocated memory has a location, right? That location will be stored in pointer. So that's the function of malloc. Now in calloc, what will happen? If I write like this, calloc 5 comma 2, 5 boxes will be created inside the memory, and each will be having 2 bytes. If I write here 3, each will be of 3 bytes, and if I write here 6 comma 3, 6 spaces will be created which will be of 3 bytes each. That location will be stored in pointer. Okay, that's the function of calloc. Now coming to realloc, in realloc what will happen? Initially you will have a pointer here. Okay, this will be pointing to 20 bytes inside the memory. Now if I want to increase this size, what can I do? I'll write realloc pointer comma 40, so pointer will be increased to 40 bytes. Okay, and in free what will happen? If I have used this memory and I don't need it anymore, what I can do, I can free that space so that this space can be utilized for other operations. I'll use by free, in bracket I'll write the pointer, so this pointer's memory will be free. We have discussed 1D array. Now if you have to have the rows and columns, and you will allocate it by using int a 3 4. What does 3 4 mean? 3 rows and 4 columns. So this grid will be created inside the memory which will be having the name a, and 3 rows will be there and 3 columns will be there. That is 2D array. Consider this polynomial 4x cube plus 6x square plus 7x plus 9. Now what's the coefficient of x here? 4. What's the power of x here? 3. This has the coefficient 6 and the power 2. Similarly, if I have to store this in an array, I can just store within this small space. Now let's see how it works. See here, the array starts from 0 till 4. Now what does this represent? This represents the exponent. Okay, means this is having 3, right? So at third space what will be stored? 4 will be stored. This exponent 3, the x having exponent 3, that coefficient will be stored in this. The 2 exponent will be having the coefficient that will be stored here, and the 7 will be stored here and 9 will be stored here, which is having the exponent 0. I can write here like this, right? X power 0, that is 9. So 9 will be stored, and at the fourth exponent you don't have any x power 4 term, so the coefficient will be stored as 0. This is the representation of polynomial inside an array. Now a function of adding two polynomials. Consider these two polynomials p of x and q of x. 4x cube plus 6x square plus 7x plus 9, which is the previous one, and this is 3x square plus 2x plus 4. How will this be represented? 9 7 6 4. Okay, according to these exponent coefficients, and this will also be stored in the similar. And then if you have to add both of these, what you will do? In normal adding of the polynomial, you will add those coefficients which have the exponent same, right? Suppose x square and x square is there, you will add 6 and 3, right? Same thing you will do here also. See here, 9 is having the exponent 0 here, and 4 is also having the exponent 0 here. You will add both of these coefficients, 9 plus 4, and you will store in another array with the exponent values and the coefficient sums. Okay, similarly 7x and 2x will be added and stored in the first place, 9. Okay, similarly for all of this you will add and store in an array here. That is adding two polynomials. Now what does a sparse matrix mean? Suppose you have 2D array which has many elements in it. Okay, now the most of the elements, more than half of the elements, if there are 0, okay, 0 elements are most of this in this. So what you will do, you will store this big array in a smaller space, because only non-zero elements are to be considered, right? You will create a array which is having rows, columns and value. In the first one, what you will write? Number of rows this matrix has. This has 5 rows, so you will store 5 here. This has 6 columns, you will store 6 columns here. Then value means how many non-zero elements are there? 4, 8, 2, 2, 9, 5. Total 6 non-zero elements are there. You will store here 6. Then in the second row, what you will write? Start from here. Search for the first non-zero element. What does this row have? 0. So inside the row column, you will write 0. Then this column is 4, right? Inside the column, you will write 4. Then what does the value have? It is 9, right? So you will store 9 here. Similarly, then you will go here and search for the next non-zero element, and you will store the respective row and the column in these spaces and the value of the element here. Similarly, you will do for all of this, and the much larger array compressed into a smaller version. Okay, this saves a lot of space. Now coming to string, as I told you earlier that if you have to store the alphabets, you have to initialize the array as char a of 6. Char will store the alphabets in it. So if you initialize this, 6 spaces will be created, and inside that you can store any letters. Okay, and if I store apple here, the ending should be null character. This is null character. For a string, the computer needs to know when the string ends. So this character shows that string is ended. Now you have some functions. String copy. What does string copy do? Suppose this is an array which I have to copy these elements here inside different array. Okay, so what I will do, I'll copy each element in the respective positions. A will be copied here, B will be copied here, C will be copied here, null character will be at last. So the array will look like this. Okay, S2 before it was this, and after copying the S2 will be like this. The second operation is strcat. What does this do? Suppose I have two arrays. Okay, I'll concatenate both of these, means I'll join both of these. So if I use this function, this will be joined as A, B, C, D, E, F. Note here that this null character will not be copied here. After the end of the array only the null character will be present. Okay, and coming to string length, what does this do? If I use this in the function, and it will return how many letters are there inside the array. Okay, 5 letters are there, so string length will return 5. Now string compare, what does this string compare do? Suppose in dictionary you if you were to search for these two words, food and foot, which element, which word you will get earlier in the dictionary? This you will get earlier, right? So this will return a greater value and this will return a lower value if you use string compare between S1 and S2. In string reverse, you will reverse the string. If S1 is having mango, the last element of this will be copied into the first element, and the second last element will be copied into the second element, and so on. So the final S2 will be O, G, N, A, M, and the final character will be null here. In n-find algorithm, what you will have a text here and a pattern here. You are supposed to find this pattern if it is present in this text or not. Now according to n-find algorithm, what you will do first, you will compare these three characters with these three. You will compare A and A, then you will compare this and this. If a mismatch occurs, that means the pattern is not same as the selected text. So you will move the pattern one bit by the right, and you will compare again these three. Okay, and until you get the answer. Okay, if you find this pattern before the text gets over, that means the pattern is present inside the text, and you will output that. Now in KMP algorithm, what you will have a text here, and you will have to find a pattern here. Okay, this pattern you have to find inside the text. Now for that, first you have to create this pi table. Now what does this pi table do? In this pi table you will have the patterns with the numbers associated with it. Okay, now after writing this, how you will write these values? See here, A is not getting repeated, B has not occurred before, so all will be 0. If A is repeated here, you will write 1 here. B is repeated, you will write 2. See, B is here, you will write 2. Then C is also repeated, you will write 3 in increasing order. Y is not repeated, you will write 0 here. Okay, after creating this pi table, what you have to do? You have to start comparing these three elements. The first three elements match, so you will write A, B, C. Okay, with the text it matches. Then the fourth element, which is D, it doesn't match with X. See here, it's not matching with X. In that case, what you have to do? See this D here, the previous value here. Okay, this D has a previous value here as 0, right? So you will go to the 0th location and compare with X. Means A will be compared with X. That's not matching again, so you will start comparing the next element. Okay, in the next you will have these elements same as in the text. Okay, but the mismatch will occur at this position, C and X. So when you will have a mismatch, what you will do, you will see the previous location which is 2 and you will go to that particular location and start comparison from that. Now you will compare C and X, okay, that's a mismatch. So what you will do, you will see the previous location and you will go to that 0 location here and compare A and X. A and X also doesn't match, so what you will do, you will just start comparing the next element. So in next element you will have this same, and the next element still C will be same. So after that Y is not matching with D here. So in that case what you will do, you will search you will see the previous number here, previous number of Y, which is 3. So you will go to the third location and you will search the pattern from the third location. Now when you compare from the third location, A, B, C, Y is present inside the text, so that means the pattern is present inside the text. See from here, A, B, C, D, A, B, C, Y, it's present from here, A, B, C, D, A, B, C, Y. That means until all the pattern gets matched here, that in the pi table the text should be searched, and before the text gets over, if it is found, that means the pattern is present inside the text. This is the working of KMP algorithm. Stack is nothing but an array which has the elements stored in it, and you will have one pointer which will point to the top of the stack. Now what does this mean? Suppose you have to arrange many books, and you will arrange first book here, then the top of that another book, like that you will be keeping the store of books, right? And if you want any book, you will take the top book first, then the next book, right? So stack works in a similar way. You will have 3 operations: push, pop and display. Now if you have to, this will be the type of the question: convert the following expression into postfix expression using the above algorithm. Now see, if you have to convert infix to postfix expression, first you have to make 3 columns: write symbol, postfix and stack. First you will put dash here and dash here, and you will put a hash in the stack. Then after that you have to scan the symbols from the left. First symbol is opening bracket, you will write in the symbol, and postfix will have nothing, because in postfix only operators and the letters will be stored. Bracket won't be stored in postfix. Bracket will be stored in the stack, so you will write hash comma stack, hash comma bracket. Then you will scan the next symbol, which is A. A will be stored in the postfix. This stack will not get any letters here. And then next is into. This multiply sign will be not stored in the postfix, it will first get stored in this stack, okay, means hash bracket comma multiply sign, okay. Then after that it is B. B will be with postfix, you will write AB, here you will not get any letter. Then next is closing bracket. When you close the bracket, observe here what will happen. When you close this bracket, this multiply sign will come inside the postfix, and this opening bracket and closing bracket will be cancelling each other, so only hash will be remaining here. Next plus will be directly shifted to stack. Then you will have C here. C is a letter, so it will be in the postfix, and you will have plus here. Finally you will place the plus into the postfix expression. This is another question of infix to postfix. Here you will have one rule which you have to apply, which is the rule of priority, okay. See, this is the decreasing priority. First one is power, then percentage, divide and into, then the next level is plus and minus, then brackets, then hash, okay. This is the decreasing priority. Now how you will use this priority inside this? See here, you will do it normally till here, okay, and you will scan the symbol till here, okay. Then the multiply sign will be here. When this multiply sign will be here, you will shift it to the stack, and the next letter is S. You will write here S inside the postfix, QR minus S, and here hash will be there, here multiply sign will be there. Then see the next symbol, it is plus, right? So in this case what you will do, if plus is here and the stack has this into sign, okay, so what you have to do, you have to check the priority. This is the scanned symbol. If the scanned symbol is less priority than the stack, see here this plus symbol, right, plus symbol is having less priority than the stack, which is having into sign, which is having higher priority, you will shift it here. This scanned symbol will come to the stack, and this stack symbol will go to the postfix, okay. This is the rule. And then you will write T, and that will be normal, and at last plus will be placed. Evaluation of a postfix expression. In this you will be given these numbers and symbols. First you have to create a column for symbol, and here you will write all these symbols one by one, operand 1 and operand 2. Then you will write the stack here, okay. See, you have 5 here, right? that 5 will directly go to the stack, then 6 that will also go to the stack, and plus is here, right? When the operator comes, see any operator comes, then you have to choose these two last two symbols, add both of these and place the result in the stack. Okay, so 5 comma 8, then into sign is there, so you will take the last two operators, which is last two operands, which is 5 and 8, you will place here and multiply and place the result in the stack. Like that only you will do till the end, and the result is 37 here. I have made another video on factorial of a number, and it is in more depth. If you just want a brief information, you can look here only. Now see, this is the function given. Now see, what's a factorial basically? See, for 0 factorial it is fixed as 1. So whatever factorial I need to calculate, I will put here that number will be coming into this if else part. Now if the number is 0, return 1, means if the number is 0 here, 0 factorial is 1, right? So it will return 1. Now if I have to calculate 1 factorial means 1 into 0 factorial. Okay, now it's not 0. If I put here 1, then this won't be executed, it will come to the else part, return n into fact n minus 1. What is n here? It is 1, right? So 1 into fact of 0, fact of 0 is 1, so 1 into 1 will be returned, which is 1. Next, if I have to calculate the factorial of 2, what will happen? I will put here 2 and it will come to the else part, return 2 into factorial 1. Okay, 2 into factorial 1. Now then factorial 1 will be calculated again by 1 here, that 1 will return 1 into 1, that is 1. So in this part it will be returned as 1, 2 into 1, which is 2, so 2 will be returned here. Like that only for all these numbers the factorial is calculated. And recursion, this comes under recursion because see, you are calling this function again in this inside this function, right? So that's known as recursion. Second is Fibonacci sequence. In Fibonacci sequence you will have a set of numbers here. See, the first number is 0, then the second number is 1, these two are fixed. Okay, so these are denoted by f0, f1, f2 and so on. Now these numbers, how you will get the next number? See, first two numbers are here, if you want the next number you will add these two numbers, this is the this is equivalent to the sum of the previous two numbers. Okay, then if you want to calculate this number, you will add these both and this is the next number. F2, let's see how I will calculate f2. So in int n I will put here 2. Okay, if I put here 2, what will happen? Is n 0? No. N is 1? No. N is 2, right? So it will return fib n minus 1. See, it will return here down fib n minus 1 plus fib n minus 2. What is fib n minus 1? Fib 2 minus 1, fib 1 plus fib 2 minus 2, fib 0. So fib 1 plus fib 0. It will again call this function, fib 0 is 0, fib 1 is 1. So in this bottom line you will have 1 plus 0, which is 1, right? So fib 2 will be returned as 1 plus 0. Suppose that we are asked to find the GCD of 15 and 45. GCD means greatest common divisor. So how I will check that? First I will divide the bigger number by the smaller number. If it is divisible, means there remains no remainder, that means the greatest divisor is this one. Okay, so I will check that and output the greatest divisor. In case if it doesn't get divided, what I will do? First I will find the remainder here and I will divide the remainder by the smaller number. Like see, in this one the remainder is 2, right? I'll divide 6 by 2. If there remains nothing, means if it is completely divisible, then the greatest common divisor is the remainder, which is 2 here. Okay, and the next one is Tower of Hanoi. In Tower of Hanoi, what will happen? I have made this lab program video, you can watch that for more information, and for the brief information you can see here. See, for writing this function, what you need to do? First you will have 3 variables: source, temp and destination. You can remember as STD, standard. Short form of standard is STD, right? So you can remember the first three as STD. Then next you will times here tower. In the first you will write SDT. Okay, SD will be together always. Okay, S and D will be together always, and T here. In the last function, what you will write? T will come here. Okay, and SD will be shifted here. So first temp will be there, then source, then destination. In the middle you will printf moving disk from source to destination. That's easy, right? Moving disk from source to destination, that you will write in middle. Okay, now if you are, suppose you are going to a movie theater here. Okay, see, this is a movie theater here, and this is the person standing first in the queue. So this one can go this one can go into the theater first, right? Then this one will go, then this one will go. Same is with queues. In queues you will have three, you will have the elements here, and you will be having 2 pointers, front and rear. Okay, so the first you will insert elements from here and you will output the elements from here. Okay, see, if you have to remove any element, you will remove from here which came first into the stack. The elements which came first into the queue will be removed first. Okay, so in that way 1 came first, so it will be removed first, then 5 came, right? So after you remove 1, then only you can remove 5. In that way queues work. And you have some types of queues. First one is ordinary queue. In ordinary queue, if you have to insert any element, what you will do, this is the rear pointer. First you will shift this pointer to here by incrementing it, then in this empty space you will insert an element. For deletion, what you will do, you will shift this front pointer to here, so the queue will just be considered from here. Okay, this won't be considered. So in that way you can delete the element from queue. Next you have circular queue. In circular queue, the last block is connected with the first block. Okay, in that case how you will calculate the insertion and the deletion, means which location you have to insert and delete. See here, suppose I am at the position 9. Okay, so to calculate the next position, which is 0, how I will get that? R is 9, 9 plus 1, 10, 10 percentage size, how many elements are there total? 10 elements, 10 percentage 10 is 0, so 0 is the next location which I have to insert. Similarly, if I am in the 0th position, 0 plus 1 is 1, 1 percentage 10 is 1, so the next location is 1. Like that it goes on. Okay, for any element you are present now, the answer will give the next location of the element. Similarly for delete also. Third one is D queues, means double ended queues. In this you can insert or delete from the both ends, and see the new functions here are insert front and delete rear. Okay, means if you have to insert from front, you are usually deleting from front, right? Now in case you have to insert from front, what you will do, you will shift the front here, means you are decrementing the front, and you will insert the element here. For delete rear, what you will do, you will decrement the rear here, so the queue will be considered just from here. Okay, in case you want to delete 3 from rear. Priority queues means you will have a certain priority in which you have to store the elements. Okay, so suppose this is the priority and you have to store these elements, they are coming in this order. So first 1 is coming, right? So you will store 1 here, then what is coming, 4 is coming, so you will store 4 here, and then 2 is coming, but 2 is having a greater priority than 4, so 2 has to be stored here, right? So what will happen, first 1 will be stored, then 2 will be coming here, and 4 will be shifted 1 place to the right, then 6 will be stored here, and 8. Every time the priority will be checked, and in that form it will be stored. That is the priority queue. In multiple stacks and queues, you will have a big array first. Okay, these are having 20 elements, and this will be divided into 4 parts, and each one will be a stack or a queue. Okay, let's see about the stack. See, if it is divided into 4 parts, you will have 4 stacks here. Okay, for each stack you will have a top pointer which is pointing to the last location of the stack. Okay, for each stack you will have a last location, right? How you will calculate that? See, this is the formula. Suppose I have to calculate the top for first stack. What I will do, I will write top of 1 is equal to 20 is the number of elements here totally, and 4 means how many parts it is divided into, it is 4 parts. So into 1, which number of stack I am calculating for. If it is 2, I will calculate into 2. If it is 3, I will write into 3. Okay, like that, and minus 1 is common for all. Now if I calculate this, I will get the answer as 4 here. See, I will get the answer as 4 here. That means the 4th location is the last element of this stack. And if I calculate for second one, I will get answer as 9. 9 is the last location of this second stack. In that way I can calculate the top pointer.